Three climbers hang from a single rope at 18,000 feet, sliding on ice that gives no grip. This is Denali, the highest mountain in North America, and over the last century it has killed well over 100 people. Most were experienced. Most did almost everything right. The easy answer is that it's cold and high, and that's true. But it isn't the real killer. The real killer is how fast control disappears. A storm in 1967 caught a 12-man expedition high and killed 7 of them in days. The question isn't how high Denali is, it's why. Here is the number that everyone starts with: 20,310 feet. That is the official height the U.S. Geological Survey settled on in 2015, shaving 10 feet off the old figure of 20,320 that generations of climbers had memorized. It is a big number. It is not, by world standards, an extreme one. There are 14 mountains on Earth that clear 8,000 meters, and every single one of them stands more than 5,000 feet taller than Denali. Everest tops out near 29,000 feet. K2 sits above 28,000. On paper, Denali should be a serious but survivable objective, the kind of peak a fit, careful, well-equipped team knocks off in 3 weeks and flies home from with all their fingers. That is not what happens. Denali kills people who have already climbed higher. It kills people who have stood on the summit of Everest with bottled oxygen and come to Alaska thinking this would be the easy one. And to understand why, you have to throw out the height on the map and look at where that height sits on the planet. Denali is not just tall, it is tall and far north. Its summit sits at roughly 63 degrees north latitude, only a few hundred miles south of the Arctic Circle. That single fact, the latitude, is where the mountain stops behaving like its elevation and starts behaving like something much worse. To see why, you have to understand something about the air itself. The atmosphere is not a uniform blanket, wrapped evenly around the globe. It bulges. Down at the equator, where the Earth spins fastest and the air is warm, the atmosphere is deep and the column of air pressing down on you is heavy. Move toward the poles, and that column thins. The cold contracts it. The spin flattens it. So the same altitude, the same number of feet above sea level, puts you under less air the farther north you go. Less air means lower barometric pressure, and lower barometric pressure means less oxygen forced into your lungs with every breath. On the summit of Denali, the barometric pressure hovers around 360 millimeters of mercury. That is roughly half the oxygen available at sea level, packed into a body that is working harder than it has ever worked in its life. And here's the part that matters. A mountain of the exact same height sitting near the equator would offer noticeably more air than that. Physiologists who study this have run the comparison directly. If Mount Everest were somehow picked up and set down at Denali's latitude, its summit, in terms of the oxygen actually reaching a climber's blood, would effectively rise by something like 3,000 feet. The cold and the latitude would add 3,000 feet of physiological punishment to a mountain that is already the highest on Earth. Apply that logic in reverse, and Denali's 20,310 feet stops being 20,000 feet. In the way it treats a human body, the summit behaves like a peak, closer to 22 or 23,000 feet somewhere in the Himalaya. You are climbing a 20,000-foot mountain that hits you like a 23,000-foot one. Your legs feel it. Your judgment feels it more, because the first thing thin air steals is not your strength. It is your ability to think clearly about the decision that is about to kill you. So that is the first layer. Denali is higher than it looks because of where it stands on the globe. Cold, high, far north. If that were the whole story, this would be a short film. It isn't, and the reason it isn't has to do with the weather that forms around this mountain, the way the terrain funnels that weather, and the simple, brutal problem of distance. How far help is, and how completely the storm that traps you is the same storm that keeps help from coming. Hold on to that idea. We will come back to it, because it is the hinge everything turns on. Look at where Denali actually sits. It is the high point of the Alaska Range, a long arc of mountains that curves across the interior of Alaska like a wall. And Denali is not a peak among equals in that wall. It is a monster, standing alone. From its base on the surrounding lowlands to its summit, the vertical rise is around 18,000 feet. One of the largest base-to-peak rises of any mountain on the planet, larger in raw vertical relief than Everest, which starts from a plateau already 3 miles high. Denali erupts almost straight up out of country that is barely above sea level. There is nothing around it to break the wind, nothing to shelter it. It stands out into the sky by itself, a single enormous obstacle in the path of everything the atmosphere throws at it. And what the atmosphere throws at it comes mostly from the south and west, off the Gulf of Alaska and the Bering Sea. That water is a storm factory. Low-pressure systems spin up over it constantly, feeding on the temperature difference between relatively mild ocean and frigid Arctic air, and they track inland straight into the Alaska Range. When one of those systems hits Denali, the mountain does what a wall does to a wave. It forces the air up. Rising air cools, dumps its moisture as snow, and accelerates. A storm that would be merely bad out over open water becomes something else entirely when it is squeezed against and over the largest single obstacle in 1,000 miles. Winds that arrive strong leave hurricane force. And because Denali stands so far north and so high, those winds are also unbelievably cold. That combination, the wind and the cold together, is not an abstraction. It has a number, and the number was recorded by an automated weather station that scientists bolted to the rock high on the upper mountain, around 18,700 feet. On the 30th of November 2003, that station logged a temperature of minus 74.4 degrees Fahrenheit, while the wind blew at a little over 18 miles an hour. Run those two figures through the wind chill formula, and you get minus 118 degrees. That is a North American record. And here is what that number means for a human being. Exposed skin at that wind chill does not have minutes. It has less than a minute. A mistake as small as a glove pulled off to fix a buckle, a zipper that jams, a mitten dropped and rolling away down the slope, is not an inconvenience at minus 118. It is the beginning of the end of that hand. The wind is not just uncomfortable on Denali, it is the mechanism. It is the thing that turns a survivable position into a fatal one in the time it takes to make one bad decision. Now put a person into that. Not a map, not a statistic. One climber, roped to 2 others, moving across a slope of wind-hardened snow with a 50-pound pack, breathing half the oxygen their body wants, in air cold enough to freeze flesh in seconds. That is the reality the numbers are describing. Everything else in this story is about how people end up in that position, why they keep going there, and how astonishingly little has to change for it to kill them. The people who lived in the shadow of this mountain long before any of that understood at least part of it. And they understood it without a single instrument. The Koyukon Athabascan people, whose homeland spreads across the interior of Alaska north and west of the peak, gave the mountain the name we have now returned to it, Denali, most often translated as the High One or the Tall One. That name was in use for a very long time, before a gold prospector in 1896 slapped the name of a presidential candidate, William McKinley, onto it, a man who never saw the mountain and had no connection to Alaska at all. It took until 2015 for the federal government to officially restore the original name. But the name is not the important part. The important part is what the Koyukon did with the mountain, which was, essentially, to leave it alone. They knew the peak. They lived off the land at its feet, hunted its lower valleys, read its weather. And as far as the record shows, they did not climb it. This was not because they lacked the courage or the physical capacity. It was because climbing it served no purpose that justified the risk, and because their entire way of surviving in that country was built on a principle the modern world keeps having to relearn the hard way. You do not force the land onto your schedule. You move when the land allows it, and you stop when it does not. That is worth sitting with, because it is easy to romanticize indigenous knowledge into vague reverence, and that is not what this was. This was a precise, practical observation system, refined over generations, about when the country would kill you and when it would let you pass. It was knowing which slopes shed snow and when. It was reading the sky over the range and understanding that a certain look meant you did not travel. It was the discipline to sit still in a warm shelter and wait, even when waiting was frustrating, because the alternative was to be caught in the open by something that did not negotiate. Restraint was a survival skill. Knowing when not to go was as valuable as knowing how to go. Everyone who has died on Denali since has died, in one way or another. Because that discipline is very hard to maintain when you have flown thousands of miles, spent thousands of dollars, taken 3 weeks off work, and are standing at high camp with the summit finally clear above you and a weather window that might close tomorrow. The Koyukon had nowhere to be. The climbers who come now always do. That gap between the patience the mountain demands and the schedule the climber arrives with is the oldest trap on Denali, and it has never stopped catching people. For a long time, the mountain simply won by default because nobody had a compelling reason to fight it. That changed at the turn of the 20th century, when the mountain stopped being a fact of the landscape and became a prize. The height that made it dangerous also made it desirable. It was the tallest thing on the continent, and that made it something to be claimed. The first serious attempts were tangled in fraud and bitterness. A 1906 claim of success by the explorer Frederick Cook that was later thoroughly discredited. A 1910 push by a group of Alaska miners, the so-called Sourdough Expedition, who hauled a spruce pole up the lower of the mountain's 2 summits to prove they had been there. The real prize, the higher south summit, stayed untouched. It fell on the 7th of June, 1913. The expedition that did it was led by Hudson Stuck, an Episcopal missionary and the Archdeacon of the Yukon, a man who had spent years traveling the Alaskan interior by dog sled and had come to know the country and its people. But Stuck was not the strongest climber in his own party, and he knew it. The co-leader was Harry Karstens, a tough, experienced Alaskan who would later become the first superintendent of the national park created around the mountain. There was Robert Tatum, a young theology student. And there was Walter Harper, 21 years old, the son of an Irish father and an Athabascan mother, a powerful young man who had grown up in the country the expedition was crossing. 2 younger Gwich'in Alaska natives, John Fredson and Esaias George, supported the climb from the lower camps. On summit day, Karstens made a decision that tells you everything about how these men understood the mountain. He put Walter Harper in front. The strongest member went first, breaking trail, chopping steps into the ice hour after hour up the final ridge. And so it was Walter Harper, an Athabascan man whose people had watched this mountain for centuries without needing to stand on top of it, who became the first human being to set foot on the true summit of Denali. His teammates joined him minutes later. Stuck, by his own account, was so worked by the altitude that he nearly passed out at the top while the younger men took in the view. They had proven it could be done, and that, it turned out, was the dangerous part. Because a mountain that has been climbed is a mountain that will be climbed again by people who read the account, look at the route, and think, if they could do it in 1913 with wool coats and hemp rope and food they cooked over a Primus stove, then surely I can do it now. The 1913 ascent did not tame Denali, it advertised it. And it hid inside the clean triumph of that first summit, a fact that would take decades and a great many bodies to fully expose. That reaching the top of this mountain in good weather, with everything going right, tells you almost nothing about what it does to you when the weather turns and everything starts going wrong at once. For 54 years after that first ascent, the mountain kept a kind of grim balance. People climbed it, people died on it, but no single event had shown the world the full scale of what Denali could do when it decided to unleash everything at once. Then came the summer of 1967, and a storm that mountaineers still study, and a disaster that remains the deadliest in the mountain's history. It began as an ordinary ambition. A young man named Joe Wilcox, 24 years old, a graduate student, organized an expedition to climb Denali by the West Buttress, the route that had by then become the standard way up. Wilcox recruited 8 other men to go with him. They were not elite alpinists. They were strong, motivated amateurs, the kind of party that made up most of the traffic on the mountain. Late in the planning, a separate group of climbers from Colorado, led by an experienced climber named Howard Snyder, lost a member and could no longer meet the park's requirement for a minimum party size. The two groups were pushed together by circumstance into a single expedition of 12. They were not a unified team. They had trained apart. They barely knew each other. And the friction between Wilcox and the Colorado climbers over who was really in charge would haunt the story for decades. Remember that friction. It matters later, but not in the way you might expect. Through late June and early July, the combined party worked its way up the mountain in reasonable weather, establishing camps, ferrying loads, doing everything a competent expedition does. By mid-July, they were high on the mountain, and the summit was within reach. On the 18th of July, a first group from the expedition reached the top. This is the detail that makes the whole thing so hard to look away from. They succeeded. Part of the team stood on the summit of Denali in decent conditions and came back down to the high camp alive. The objective had been achieved. If the story had ended there, it would be a footnote. But an expedition is not one summit push. Several men had not yet had their chance at the top, and the plan was for a second group to go up. On the night of the 17th into the 18th, and again as the days ticked past, the weather was holding. There was every reason to think there would be time for everyone. Continuing looked entirely reasonable. That is the thing to hold on to about Denali disasters. They almost never start with a reckless decision. They start with a reasonable one, made in conditions that have not yet turned, by people who cannot see what is coming. Because in 1967, nobody could see what was coming. Because here is the piece of the machine that was missing. In 1967, there was no way to get a reliable, timely, mountain-specific weather forecast to a party high on Denali. Satellite weather imagery was in its infancy. The climbers had a radio, but what a radio gives you is communication, not prediction. They could talk. They could not know. They were, in the most literal sense, blind to the atmosphere assembling itself out over the Bering Sea and the Gulf of Alaska, and beginning to move towards them. And what was moving toward them was not an ordinary Denali storm. It was, by the reckoning of people who have studied it since, very possibly the worst storm to strike the mountain in a century. The second summit group went high. 7 men ended up committed to the upper mountain, near the 18,000-foot camp at Denali Pass and above, when the storm arrived. And when it arrived, it did not pass. This is the single most important fact about the 1967 disaster, and it is the fact that separates Denali from mountains that merely have bad weather. The storm sat on the summit for days, not hours, days. Sustained winds that observers and later analysts estimated at well over 100 miles an hour, temperatures far below zero, and a wall of blowing snow that erased the world. The 7 men on the upper mountain were pinned. They could not climb up, and they could not climb down because to move in that wind was to be blown off the mountain or lost in a whiteout where you could not see the person roped 10 feet in front of you. Think about what that does to the body and the equipment. A tent in a 100-mile-an-hour wind is not shelter. It is a sail being torn apart, and the people inside spend their strength just holding it together, bracing the poles with their hands and backs hour after hour. The stoves that melt snow into drinking water struggle in the cold and the shaking. Without water, dehydration sets in fast at altitude, and dehydration thickens the blood and accelerates frostbite and clouds the mind. Food that requires cooking becomes hard to prepare. Every hour the storm continues, the margin shrinks. Less fuel, less water, less warmth, less strength, less clear thinking. The storm was not trying to kill them in a single blow. It was doing something slower and more certain. It was outlasting them. It was waiting for their supplies and their bodies to run down, and it had all the time in the world. The men at the lower camps could do nothing. This is the part that breaks people who read the accounts. 5 members of the expedition were lower on the mountain, safe enough, and they could sometimes make radio contact, and they could hear that their teammates above were in desperate trouble. And there was absolutely nothing they could do about it. To climb up into that storm would simply have added their bodies to the count. Below them, on the ground, the same wall of weather that was killing the men up high made any rescue impossible. Aircraft could not fly into it. No one on the ground could climb into it. The storm that was killing the climbers was the exact same storm that guaranteed no one could reach them. That is the trap in its purest form, and it is worth naming clearly because you will see it again and again on this mountain in every era, with every level of technology. The conditions that create the emergency are the same conditions that prevent the rescue. They are not 2 problems. They are 1. The radio contacts grew more fragmentary, then stopped. When the storm finally broke and the wind dropped enough for people to move and for aircraft to fly, the mountain was searched. What they found told the story in pieces. 2 bodies were located near Archdeacon's Tower, a formation just below the summit, meaning at least some of the men had been caught high, possibly on the descent from a summit attempt made in a brief lull. Another body was found at the high camp, still holding onto a tent pole, a detail that tells you exactly what that man had been doing when the cold finally won, which was fighting to keep the shelter up. 4 of the 7 were never found at all. The mountain simply kept them. They are still up there somewhere, under the snow and the moving ice, where they have been for approaching 60 years. 7 dead. Jerry Clark, 31. Steve Taylor, 22. Dennis Luchterhand, 24. Mark McLaughlin, 23. Hank Janes, 25. John Russell, 23. Walt Taylor, 24. Young men, most of them, who had climbed the mountain and in several cases actually reached its summit, and who died not because they failed, but because the weather decided to stay. And then came the argument, which lasted longer than any of their lives had. Because when a disaster is this large and this public, the survivors and the public and the writers who come after all want the same thing. They want to know whose fault it was. The blame fell in every direction. Some pointed at Joe Wilcox and the fractured leadership of a team stitched together from 2 groups that never fully merged. Some pointed at the decision to split the party, to let a second group go high when the first had already succeeded. Howard Snyder, one of the Colorado climbers who survived, wrote a book, The Hall of the Mountain King, that was sharply critical. Wilcox wrote his own account, White Winds, defending the expedition's decisions and laying the deaths at the feet of the storm. Decades later, the writer James Tabor, in Forever on the Mountain, went back through the record and spread responsibility more widely, including onto the Park Service and the systemic conditions of the era. Most recently, the Alaskan writer Andy Hall, whose father was the park superintendent at the time, wrote Denali's Howl, which returned again to the sheer meteorological violence of what hit them. Here's where you have to be honest about what is known and what is not. The exact sequence of who died where and in what order, and whether a different decision on a specific day would have saved them, is not fully knowable. The men who could tell us are the men who did not come back. What the surviving evidence supports is narrower and, in a way, more disturbing than any blame narrative. It is this: a party of ordinary competence, having actually achieved its goal, was caught high on the mountain by a storm of extraordinary and sustained violence that no available technology of 1967 could have warned them about in time. And once they were caught, no rescue was physically possible until the storm chose to end. You can argue about the leadership all you want. The storm did not care about the leadership. The storm cared about how long they could last, and it lasted longer. That is what 1967 newly proved. The thing that no earlier death on the mountain had shown so completely. It proved that Denali's real weapon is not a single moment of danger, but duration. The capacity to seal off the top of the mountain for days at a stretch and simply wait for people to run out of everything they need to stay alive. A rockfall kills in an instant and is over. An avalanche is a matter of seconds. But a multi-day storm at altitude is a siege, and the mountain has infinite patience, and the climbers have finite fuel. The lesson was not that these particular men made a particular mistake. The lesson was that the trap could close on anyone, and that the deciding factor was something no amount of courage or fitness could change: how long the weather held them versus how long they could hold out. So the survivors came down, and the investigations were written, and the mountaineering world absorbed the shock. And the natural response, the human response, was to ask how to make sure it never happened again. The answer everyone reached for was information. If the killer was a storm they could not see coming, then the solution was to be able to see it coming. Give the climbers a forecast. Give them a radio link to meteorologists. Give them, eventually, satellite imagery and weather models, and the ability to know, days in advance, that a system was building over the Bering Sea and tracking toward the range. Surely, with warning, no one would ever again be caught high on Denali by a storm they didn't know was coming. It is a reasonable idea. It is even partly true. Forecasting on Denali today is vastly better than it was in 1967, and it has certainly saved lives by turning parties around before they committed to the upper mountain. But hold that optimism loosely, because it contains a hidden flaw that the mountain would expose within a couple of decades. A forecast tells you a storm is coming. It does not move your body down the mountain. If the storm is coming faster than you can descend, or if it arrives while you are already high, or if you are alone and something has already gone wrong, then knowing is not the same as escaping. Information solved the problem of surprise. It did not solve the problem of distance or of time, or of the simple physical fact that getting down off the upper mountain takes hours you may not have. The next chapter of Denali's history would be written by a man who had the best information available, who did everything with more skill than almost anyone alive, who was not surprised by anything, and who vanished anyway. His name was Naomi Uemura, and by the time he came to Denali in the winter of 1984, he was arguably the most accomplished adventurer alive. He was Japanese, small and unassuming in person, and he had spent his life doing things alone that most people would not attempt in a large team. He had rafted the Amazon solo. He had made the first solo journey by dog sled to the North Pole. He had climbed the highest peak on 5 continents. He understood cold and isolation and self-reliance at a level almost no one on Earth could match. And he understood Denali specifically because he had already climbed it once before, in summer, years earlier. He was not a tourist walking into a trap he didn't understand. He understood the trap better than the people who built the forecasts. What he wanted was something no one had ever done: to climb Denali alone, in the dead of the Alaskan winter. Winter on that mountain is a different planet from the summer climbing season. The cold that produced that minus 118-degree wind chill reading was a winter number, recorded at the end of November. The days are short. The storms are more frequent and more violent, and Uemura wanted to face all of it by himself, with no partner to share a tent's warmth, no one to pull him out of a crevasse, no one to go for help. Solo, in winter, on a subarctic mountain that killed roped teams in summer. It was, on paper, close to the definition of unsurvivable. He had made a career out of doing things that were close to the definition of unsurvivable and surviving them. He had communication, which is the thing 1967 lacked. He carried a radio and was in periodic contact with a support team, including a pilot who flew the small aircraft that are the lifeline of Denali climbing. This is the technology that was supposed to close the gap the Wilcox disaster had opened. He would not be blind. If something went wrong, he could call. People would know where he was and what was happening. In theory, that changed everything. On the 12th of February, 1984, his 43rd birthday, Naomi Uemura reached the summit of Denali, alone, in winter. It had never been done. It was, and remains, one of the great feats in the history of mountaineering. He radioed his success. The people supporting him knew he had made it. And then he started down. The descent is where Denali does most of its killing, and it does not care how famous you are. On the 13th of February, the day after the summit, Uemura made radio contact again. He confirmed the summit. He reported his position, somewhere on the upper mountain, descending. And that was the last anyone ever heard from him. The radio went silent. The contact that was supposed to be his safety net simply stopped. And on the other end of it, his support team was left holding exactly what the men at the lower camps had held in 1967. The knowledge that something was wrong, and no ability to reach him. The weather closed in. Searches were mounted when it was possible to fly, which was not often and not for long. Other climbers went up. They found traces, a snow cave he had dug, some of his equipment, marks of his passage, but they did not find him. Naomi Uemura was declared dead in late February 1984 at 43 years old. More than 40 years later, his body has never been found. The greatest solo adventurer of his generation walked up into the winter and did not come back, and the mountain has never given him back. What killed him? We do not know, and it is important to be honest that we do not know, because the temptation is to invent a dramatic final scene, and there is no evidence for any particular one. He may have fallen. He may have gone into a hidden crevasse the way climbers do, roped to no one because there was no one to rope to. He may have been caught in the open by the cold and simply run out of the strength to keep moving. What the record supports is only the shape of it. He summited. He reported it. He descended. And somewhere on that descent, alone, in winter, on the upper mountain, the margin that he had shaved thinner than any human being had ever shaved it finally went to zero. And here is what his death newly proved, the thing that 1967 had not. The Wilcox party died, partly because they could not see the storm coming. Uemura saw everything. He had the radio. He had the support team. He had the communication that was supposed to be the answer. And it made no difference, because communication is not rescue. He could tell people he was in trouble. He could not shorten the distance between himself and help. He could not conjure an aircraft into a winter storm on the upper mountain. The technology that had been invented to solve the 1967 problem solved a different problem than everyone assumed. It solved knowing. It did not solve reaching. A man could now report his own success and then vanish inside the same silence, because the mountain's isolation was never really about a lack of information. It was about distance and cold, and the physical impossibility of getting a rescuer to a specific point high on Denali in bad weather fast enough to matter. Woomera had closed one gap and fallen straight through the one that was still open. That gap, the distance, the reaching, is the thread that runs from Woomera forward into the modern era. And to understand why it keeps killing people, you have to understand why people keep coming and how many of them there now are. Because the mountain did not get quieter after these disasters. It got busier. Much, much busier. For most of the 20th century, climbing Denali was a rare and serious undertaking reserved for expeditions. Then, gradually, it became something a fit member of the public could buy. The mechanism was the guided climbing industry and the bush aircraft that fed it. This is the technology that changed Denali more than any forecast or radio. The ski-equipped small plane. Pilots learned to land these aircraft on the Kahiltna Glacier at around 7,200 feet, on a broad, relatively flat expanse of ice that became known simply as Base Camp. Before that, reaching the base of the West Buttress route meant a long, grueling overland approach on foot. The airplane erased it. Now a climber could fly from the little town of Talkeetna and, 30 or 40 minutes later, step out onto the glacier at the start of the route. The approach that once took days and filtered out the unprepared was gone. That single change transformed the mountain. It made Denali accessible to hundreds of people a year, then over 1,000. Guide services built businesses around it. The West Buttress became a highway by the standards of high-altitude mountaineering, a route where in the peak season of May and June, you might share the trail with dozens of other climbers and camp in established sites dug into the snow by the parties before you. And every one of those people arrived with the same problem the Koyukon had solved by staying home, and that Joe Wilcox's party had run straight into: a schedule, a flight home, a guide's set itinerary, a finite number of days to reach the top before the money and the vacation ran out. Understand the pressure that creates, because it is the same pressure in every era, only now multiplied across a crowd. You have flown to Alaska. You have paid a guide service a large sum of money. You have a permit, a plane slot out, a life waiting for you at home. You are at the 14,000-foot camp, and the summit is above you, and the weather is marginal. Not clearly deadly, just marginal. And the forecast says it might improve tomorrow or it might not. And you have 3 days left before your window closes. What do? The mountain's answer, the Koyukon answer, is to wait. And if the weather doesn't cooperate, to go home without the summit. The human answer, over and over, is to go. Because you came all this way. Because you might not get another chance. Because the storm hasn't actually started yet. Most of the time, that gamble pays off and everyone comes home. The days it doesn't pay off are the days that fill the mountain's list of the dead. 61% of the people who have died on Denali died on the descent, which is to say they died coming down from a summit they reached often later in the day than they should have, more tired than they planned, in weather that was turning while they were still committed to the top. The airplane, in other words, did exactly what technology tends to do on this mountain. It solved a real problem, access, and in solving it, it created a new and larger exposure. It did not make the upper mountain any less cold, any less high, any less prone to week-long storms. It simply delivered far more people to the bottom of the danger, most of them on a schedule, and let them climb up into it. The number of ways to die did not change. The number of people positioned to die did. This is the pattern you have to keep watching for, because it is the deep logic of the whole story. On Denali, the tools that make the mountain more accessible do not make it safer. They enlarge the pool of people exposed to a set of physical dangers that no tool has ever been able to touch, and the guiding industry, for all its professionalism, could not repeal physics. A guide can carry more experience and better judgment, and a satellite phone and a detailed forecast. A guide cannot make the air thicker, or the wind warmer, or the crevasses shallower. A guide can turn a client around, and good ones do. And that discipline saves lives. But a guide is also under a version of the same pressure. Clients who paid to summit, a reputation built on getting people to the top, the human difficulty of saying no when the weather is merely marginal. The professionalization of Denali climbing raised the floor. It did not remove the ceiling. And the season that proved just how hard that ceiling is, the season that saw more people die on the Alaska Range than any before or since, was still coming. And it would take not amateurs, not the unprepared, but some of the most skilled climbers on the mountain, including one of the finest alpinists America ever produced. The year was 1992, and by the count that the Park Service and the American Alpine Club keep, it remains the deadliest climbing season in the history of the Alaska Range. 11 people died. It was also, in the words of the people who ran the mountain that year, the most intense period of rescue Denali had ever seen. A season where the rangers and the volunteer climbers and the pilots went from one emergency to the next with barely time to breathe between them. And the reason it matters so much to this story is what it proved about who dies on this mountain. 1967 could be waved away as a fractured amateur expedition caught by a freak storm. Wiemera could be called a man who pushed past all reasonable limits alone. 1992 was neither. 1992 killed the skilled. Start with the crevasses, because the Kahiltna Glacier that every West Buttress climber walks up is not solid ground. It is a river of ice, moving slowly downhill, and where it bends and stretches, the ice cracks open into crevasses. Some of them narrow enough to step over, some of them wide and deep enough to swallow a bus. In the cold, snow bridges form over these cracks, roofs of packed snow that hide the void beneath. Early in the season, when it is cold and the snow is deep, those bridges are strong. As the season warms, they weaken. A climber walking across an apparently unbroken snowfield may be walking across a series of hidden roofs over drops of 100 feet or more, and the only defense is the rope. Climbers travel tied together, so that if one breaks through, the others can catch the fall and haul them out. The rope is everything. On a glacier, the rope is the difference between a fall and a death, which is what makes the death of Mugg Stump so hard to absorb. Terrence Stump, known to everyone in the climbing world as Muggs, was not an ordinary climber. He was one of the greatest alpinists the United States has ever produced, a man famous for bold, brilliant ascents in Alaska and Antarctica and beyond. The kind of climber other elite climbers spoke about with awe. In May of 1992, he was on Denali working as a guide, leading 2 clients down from the South Buttress, a more demanding route than the standard West Buttress Highway. He knew crevasses. He had spent his life around them. He understood the danger better than almost anyone breathing. They were descending. Ahead of them lay a crevasse that had to be crossed, and Stump, as the experienced leader, went ahead to check the route across it, to find the safe way over. Here the record identifies the small, human, fatal detail. In moving ahead to scout, he left a length of slack in the rope between himself and his clients. Slack in the rope is the one thing you cannot afford on a glacier, because the rope only saves you if it is tight enough to catch you before you have fallen far. When the lip of the crevasse collapsed beneath Mugg's Stump, he did not fall a few feet onto a taut line and hang there to be pulled out. He fell deep into the crevasse, and the collapsing snow and ice fell in on top of him and buried him. One of his clients descended into the crevasse, went down twice, into the cold and the dark and the unstable ice trying to find him. He could not. There was nothing to find that could be reached. The two clients, shaken and alone, continued down the mountain and reported the accident the next day, on the 22nd of May. Mug Stump's body was never recovered. Like the four from 1967, like Wamura, he is still up there. It is worth understanding why the rope so often fails to save a person in exactly this situation, because it explains why crevasses kill even expert teams. When a climber breaks through a snow bridge on a taut rope, the fall is short. The teammates throw themselves down to arrest it, and the trapped climber ends up dangling a few feet down, cold and frightened, but alive, and can be hauled out with a system of pulleys and knots that every competent glacier team carries and practices. The whole method depends on the fall being short. It depends on the rope coming tight almost immediately, before the falling body has picked up speed, and before the collapsing lip can bury it. Slack destroys all of that. A few extra feet of loose rope means the climber falls farther and faster, wedges deeper, and is buried by the snow and ice that comes down on top of them. And a buried climber cannot be reached by a pulley system, because the problem is no longer lifting a hanging weight. It is digging a person out of packed, refrozen debris at the bottom of a slot in the ice, in cold, with tools you do not have. That is the situation Stump's client faced, rappelling twice into the crevasse and finding nothing he could free. The mechanism that saves glacier climbers is measured in feet of slack, and Mug Stump, who knew that better than almost anyone alive, was caught by the one detail he could not afford. Consider what that death proves, because it is the hinge of the whole modern half of this story. The single most skilled person in that rope team was the one who died, and he died not from a storm, not from the altitude, not from any exotic hazard, but from a routine glacier crossing and a small margin of slack in a rope. A thing that could catch anyone, and that catches people precisely because it happens during the ordinary, tired, let-your-guard-down work of getting down. Skill did not exempt him. Fame did not exempt him. The trap on Denali is not reserved for the incompetent. It is structural. It is built into the terrain and the ice and the human body's limits, and it is waiting on the descent when the summit is behind you and the hard part feels over, and it absolutely is not. But Mug Stump was one death in a season of 11, and the rest of that summer showed the trap operating on every kind of climber at once. 1992 was a year of storms and of crowding, and the two together overwhelmed the system. A violent storm struck the upper mountain in May and stranded multiple parties high, in exactly the position the Wilcox expedition had been in 25 years earlier, pinned above the reach of easy rescue, burning through their supplies, while the wind screamed and the temperature fell. But now there were far more people on the mountain, which meant far more people caught at once. Different expeditions from different countries were scattered across the high camps, and as the storm and the cold and the altitude went to work, the emergencies multiplied faster than anyone could respond to them. Climbers from several nations died that season. Some froze, some fell, some succumbed to the altitude itself. The specific stories varied, but the underlying machine was the same one that had run in 1967 and would run again. The mountain seals off the top, the weather refuses to lift, and the people caught up high, run down their reserves while everyone below can only wait. What was different in 1992 was the rescue effort, and it is worth slowing down on that, because rescue on Denali is not a helicopter appearing over a stranded climber. It is a long, staged, dangerous process, and every stage can fail. It begins with the National Park Service's mountaineering rangers, who run a camp at 14,200 feet on the West Buttress, a permanent presence high on the mountain during the climbing season, staffed by rangers and volunteer patrol members who are themselves strong climbers. That camp exists precisely because the mountain generates so many emergencies that it made sense to station help partway up it. When something goes wrong above, the response often starts there, with rangers and volunteers climbing towards the problem on foot, because for much of the upper mountain and in much of the weather, there is no other way to reach it. For the parts that can be reached by air, the Park Service came to rely on a specialized high-altitude helicopter, a machine light and powerful enough to operate in the thin air, where ordinary helicopters cannot generate enough lift. But even that aircraft has hard limits. It cannot fly in the storm. It cannot always land on the steep, hard, wind-scoured slopes where climbers fall, which is why rescuers developed the technique of the long line. Dangling a rescuer or a rescue basket beneath the helicopter on a rope, lowering them to a spot the aircraft itself cannot touch, plucking an injured climber off a slope where there is nowhere to set down. It is a delicate, risky operation, flown at the edge of what the machine and the pilot can do, in air where the margin for error is already almost gone. And it only works when the weather allows the helicopter to fly at all. Which brings you straight back to the trap. The worse the emergency, the worse the weather that usually caused it, and the worse the weather, the less any aircraft can do. In 1992, the rescuers went out again and again in the narrow windows they were given, and they saved people, and some people they could not reach in time, because the windows were not wide enough. There is a further, colder truth buried in that rescue effort, and it is one this mountain forces on everyone who works it. The rescuers are exposed to the same mountain as the people they are trying to save. A ranger climbing toward a stranded party is climbing in the same cold, the same altitude, the same avalanche and crevasse terrain. A volunteer on a long line under a helicopter is hanging in the same wind. Over the decades, rescue on Denali has injured and endangered the people performing it, because there is no way to help someone in that environment without entering that environment. The help does not arrive from outside the danger. It has to walk or fly into the danger, and it can be caught by exactly the same forces. This is not a mountain where safety comes from somewhere else. There is no somewhere else. There is only the mountain, and everyone on it, climber and rescuer alike, is subject to the same physics. So the registration and permit system that the Park Service put in place in 1995, a few years after that catastrophic season, was an attempt to attack the problem at its root. To screen climbers, to require pre-registration, to give the rangers a way to know who was on the mountain, and to push the least prepared parties toward better preparation before they ever flew to the glacier. And it worked in a measurable way. Studies of Denali fatalities found that the death rate dropped substantially after the mid-1990s reforms, by something on the order of half. That is a real achievement. And it deserves to be said plainly because the story of this mountain is not that nothing can be done. Things can be done. Screening helped. Ranger patrols helped. Better forecasting helped. The overall rate at which climbers die on Denali has genuinely declined. And yet, the reforms changed who gets onto the mountain and how prepared they are. They did not change the mountain. They could not touch the barometric pressure, or the storms off the Bering Sea, or the crevasses under the snow bridges, or the distance a rescuer has to travel, or the fact that the descent will always be when you are most tired, and the terrain will always be waiting. The measures worked on the human side of the equation, the side that humans can actually reach. The physical side, the geography, the weather, the altitude, the isolation, stayed exactly as lethal as it had always been. Which is why, even now, in an era of satellite phones and detailed forecasts and professional guides and a permanent rescue presence on the mountain, people still die on Denali in the same places, by the same mechanisms, for the same reasons. And there is one place in particular where they die more than anywhere else. A single stretch of the upper mountain that has been killing descending climbers for as long as people have been climbing there. And that concentrates everything this mountain does into a few hundred yards of hard, tilted ice. That place is Denali Pass and the slope that leads up to it. And to understand why it kills more people than any other stretch of the standard route, you have to picture exactly where it sits in a climber's day. The highest camp on the west buttress is at 17,200 feet, a cluster of tents and snow walls dug into a shoulder of the mountain. From there, summit day is a long, brutal push of more than 3,000 vertical feet to the top and back, most of it above 17,000 feet, all of it in that thin subarctic air. And the very first obstacle out of that high camp, the thing a climber has to cross within the first hour or two of the summit push, is a traverse, a long, angled slope of snow and ice that climbs across the face toward the notch of Denali Pass at around 18,200 feet. The guides have a name for that slope. They call it the Autobahn. It is not a compliment. It is a sheer tilted sheet that can be soft snow one week and bulletproof ice the next, and it has been the site of more deaths than any other single section of the West Buttress. And the reason is a piece of pure, cruel geometry. The traverse is angled. If you slip on it and you are not held by a rope anchored to something solid, you do not stop. You slide, and the slope funnels you, and you accelerate down thousands of feet of mountain until something stops you, and nothing good stops you. It is the kind of terrain where a single lost footing, a crampon that skates on hard ice, a moment of imbalance, turns instantly into a fall that cannot be arrested. Now layer the human condition on top of the geometry, because that is what makes the Autobahn so lethal. The climbers crossing it are not fresh. On the way up, they are already high and already tired, and their bodies are already gasping in half the oxygen they want. On the way down, which is when most of the deaths happen, they are wrecked. They have been to the summit. They have been on their feet for 10, 12, 14 hours. They are dehydrated, hypoxic, cold, and running on nothing. And their fine motor control and their balance and their judgment have all quietly degraded without their noticing, because that is what altitude does. And this is the moment, this exact moment, when they have to recross the Autobahn, the hardest, most exposed, least forgiving piece of ground on the route, to get back to the tents. The mountain puts its deadliest terrain at the point in the day when the climber is least equipped to handle it. That is not bad luck. That is the structure of the trap. This is the deeper answer to a question that has been building since the first ascent. Why do the strongest climbers, the ones who make the summit, so often die coming down? 61% of Denali's dead died on the descent. It sounds backwards. Getting to the top is the hard part, the dangerous part, the part everyone trains for. But reaching the summit is not the achievement your body treats as the finish line, and the mountain does not reward you for getting there. The summit is the halfway point of the most dangerous day, and it is reached, almost by definition, by people who have just spent everything they had to reach it, and who now have to perform the most delicate and exposed movements of the entire climb with an empty tank and a brain running on half its oxygen. Summit fever gets you up. It does not get you down. The descent is where the bill comes due, and Denali Pass is the counter where it is paid. The historical record on that slope is a long, repeating list, and the specifics are almost monotonous in their similarity. Which is exactly the point. A climber descending on the traverse falls, sometimes roped, sometimes not, sometimes the whole team pulled off together. An Italian climber died in a fall from Denali Pass. Climbers of many nationalities have died there, across many decades. And the Park Service's own summaries return to the same section again and again. When the same kind of accident happens in the same place to different people across half a century, You are no longer looking at a series of individual mistakes. You are looking at a property of the mountain. The Autobahn does not kill because the people crossing it are careless. It kills because it combines the worst terrain with the worst moment, and it does so for everyone, expert and amateur alike. The most recent chapter of that list was written in the spring of 2026, and it is worth telling in full because it shows the trap operating exactly as it always has in the present day, with all the modern advantages in place. A 7-member expedition of Latvian climbers was ascending the West Buttress, near Denali Pass at around 18,200 feet. On that same traverse, at that same altitude, 4 of the 7 fell. The 3 remaining members managed to get themselves back down to the high camp at 17,000 feet and raise the alarm. The rescue that followed shows you the whole machine in miniature. The terrain where the climbers had fallen was too steep and the conditions too poor for the high-altitude helicopter to land, so the rescuers used the long line, dangling beneath the aircraft to reach a spot the helicopter could not touch. One of the 4 fallen climbers was still alive, and that person was extracted, flown down to the Kahiltna base camp, and transferred to an air ambulance for the flight to a hospital. The other 3 could not be saved. The operation for them shifted, in the Park Service's careful language, from rescue to recovery. 3 dead, 1 alive, on the descent, on the Autobahn in 2026, with satellite communication, with a permanent ranger presence, with a specialized rescue helicopter, with modern equipment and clothing that the men of 1967 could not have dreamed of. Every technological answer that the last 60 years produced was present on the mountain that day, and 4 people still fell on the same slope that has been catching people since climbers first started using this route. That is not an argument that the technology is worthless. The one survivor is alive because of it. It is an argument that the technology operates on one side of the problem and the mountain operates on the other, and the mountain side has not moved an inch. There is a monument to that permanence, bolted to the rock up near Denali Pass, and it has nothing to do with climbing, and everything to do with why climbing there is so dangerous. In the years after a fatal accident involving Japanese climbers in the late 1980s, a team from the Japanese Alpine Club installed an automated weather station high on the mountain, at around 18,700 feet, to record the conditions that kept killing people up there. That station became one of the most valuable scientific instruments in high-altitude meteorology, precisely because it sat in one of the most savage spots on the planet and simply kept recording, year after year, what the air did to anything exposed to it. It is that station that captured the numbers that put the danger beyond argument. Remember the figure from the beginning, minus 118 degrees of wind chill, recorded at the end of November 2003, from a temperature of minus 74 and a wind of 18 miles an hour. 18 miles an hour is not even a dramatic wind. It is a breeze by the standards of a real Denali storm, where gusts run to 100 miles an hour and more. And at that modest wind speed, combined with the winter cold, the station recorded a wind chill that would take exposed flesh past the point of no return in well under a minute. That is the environment the Autobahn sits in. That is what is waiting for a climber who crosses it tired and hypoxic and then loses a mitten, or has to stop and work with bare hands on a frozen buckle, or falls and is knocked out and lies still on the ice for even a few minutes. The cold does not need a 100-mile-an-hour storm to kill you up there. It can do it on a light breeze, in the time it takes to lose your grip. But cold and falling are the dangers people expect, the ones that fit the picture of a killer mountain. There is a third killer on Denali that fits no such picture, that arrives without a storm and without a slip, and that is responsible for more evacuations than anything else on the mountain. It is the thin air itself, working from the inside, and it kills people who never fell and never froze. Go back to that barometric number, 360 millimeters of mercury at the summit, half the oxygen of sea level, made worse by the latitude. Your body does not simply feel tired in that air. It begins to break down in specific, medically predictable ways. And the two ways that kill are called high-altitude pulmonary edema and high-altitude cerebral edema, HAPE and HACE. Strip away the terminology, and here's what they are. In HAPE, the lack of oxygen causes the blood vessels in the lungs to constrict and the pressure to rise, and fluid begins to leak into the air spaces of the lungs, the very spaces that are supposed to be pulling oxygen out of the air. So the climber, already starved of oxygen by the altitude, starts to drown in their own fluid from the inside in slow motion, growing more breathless and more exhausted with every hour, coughing, unable to lie flat, getting less oxygen precisely when they need more. HAPE is the most common way the altitude itself kills on Denali. HACE is worse to watch because it takes the mind. When the brain is starved of oxygen, it swells inside the fixed box of the skull, and as the pressure builds, the person changes. They become clumsy, unable to walk a straight line, as if drunk. They become confused. Their judgment, already dulled by the altitude, collapses. They may insist they are fine when they are visibly not, may want to lie down, may stop making sense. And here's the terrible mechanics of it. The one thing that reliably saves a person with HACE or HAPE is immediate descent, getting them down to thicker air, fast, and HACE specifically attacks the part of the person that would make them descend. It steals the judgment needed to recognize the emergency and the coordination needed to walk down from it. Untreated, cerebral edema can kill within a day. A climber can be laughing at high camp in the evening and dead by the next night, from nothing but the altitude, having never touched a dangerous slope. The numbers tell you how central this is to the mountain's real danger. Altitude illness of one kind or another accounts for roughly 62% of all the evacuations on Denali. Nearly 2 out of every 3 people the rescue system has to pull off the mountain are being pulled off not because they fell or froze, but because the air itself is killing them. HAPE alone accounts for about half of all evacuations. This is not a rare, exotic complication. It is the single most common reason the rescue machine gets switched on, and it is a direct product of that latitude-driven barometric pressure that makes Denali punch so far above its height. A mountain of the same elevation farther south would generate less of this, because its summit air would be richer. Denali's air, thinned by the cold and the far north latitude, pushes climbers into the altitude illness danger zone at elevations where they might expect to be safe. The defense against it is not equipment. It is time. The discipline of ascending slowly, of climbing high and sleeping low, of taking rest days to let the body manufacture the extra red blood cells that carry oxygen, of not gaining more than a certain amount of sleeping altitude in a single day. The physiology is well understood. Give the body enough days and it adapts remarkably well. Rush it and it fails. And this is where the oldest trap on the mountain closes again, the same one the Koyukon avoided by having nowhere to be. Acclimatization takes time, and time is the one thing the modern climber on a schedule, with a flight home and a finite permit, and a guide's itinerary, is most tempted to shortchange. The airplane that drops a climber at 7,200 feet and the ambition that wants the summit in a fixed number of days are both pushing in exactly the wrong direction, toward going up faster than the body can safely follow. Every incentive that gets a person to Denali efficiently is an incentive to acclimatize too fast, and acclimatizing too fast is how the air gets you. So you have 3 killers now, and they are not separate problems that happen to share a mountain. They feed each other. The altitude that causes HAPE and HACE also degrades the judgment and coordination that would keep a climber from slipping on the Autobahn. The cold that freezes flesh in under a minute also thickens the blood and worsens the effects of altitude and saps the strength needed to descend. The storm that pins a party high keeps them at altitude longer, which deepens the altitude illness and drains the fuel and food that keep them warm. A climber high on Denali is not facing cold or falls or thin air or storms as a menu of separate risks. They are standing at the intersection of all of them at once, where each one makes the others more likely to kill, and where the standard escape from any single one of them, go down, is the very thing the terrain and the exhaustion and the swelling brain conspire to make hardest. That is the system this mountain runs, and every layer of it points the same direction, down, off the mountain, to thicker air and lower ground as fast as possible, which means that when something goes wrong high on Denali, the entire question becomes a race. How fast can a stricken climber be moved down, or reached, or flown off, versus how fast the cold or the fluid in their lungs or the swelling in their brain is closing in? And that race is run on terms the mountain sets. Because getting down under your own power may be impossible if you are already too sick to walk, and getting help up to you or a helicopter into you runs straight back into the wall that has stood since 1967 and stands today. The same conditions that create the emergency are the ones that block the rescue. To see how that wall works in the modern era, with every tool available, you have to watch the rescue system try to beat it. And watch what happens when the weather simply refuses to let it. The rescue system on Denali is one of the most developed high-altitude rescue operations anywhere in the world. And it was built the way most safety systems are built, one disaster at a time. The centerpiece is the Ranger Camp at 14,200 feet, that permanent seasonal outpost partway up the West Buttress, staffed through the climbing season by National Park Service mountaineering rangers and volunteer patrol members who are themselves elite climbers, often with medical training. The camp has a medical tent. It has, at times, a hyperbaric chamber, a sealed bag a patient can be placed inside and pressurized, which simulates a descent of thousands of feet without the patient having to move a muscle, buying time for a brain or a pair of lungs that cannot wait. It has communications. It exists because the mountain generates so many emergencies, so predictably, in the same stretch of altitude, that stationing a rescue capability at 14,000 feet was simply the rational response to the body count. Above the camp, for the emergencies that happen higher, the tool of last resort is the helicopter, a specialized, lightweight, high-powered aircraft capable of flying and hovering in air too thin for ordinary machines. Flown by pilots who operate at the extreme edge of what is aeronautically possible. When it can fly, it is close to miraculous. It can pluck a climber off the mountain in minutes that would otherwise take a ground team days. But that phrase, when it can fly, is doing an enormous amount of work, and it is where the entire modern illusion of control runs into the same wall the Wilcox Party hit in 1967. A rescue on Denali does not begin when the helicopter arrives. It begins with recognition, someone, often a teammate or a nearby party or a ranger, realizing that a climber is in serious trouble, which is itself not guaranteed when the victim has haste and is insisting they are fine, or when the party is small and everyone is impaired. Then comes the call, and the decision, and the authorization. The incident has to be assessed, resources committed, a plan made. Then preparation, the aircraft readied, the team assembled, the gear staged. Then travel, the flight up from Talkeetna, or the launch from base camp, or the ground team beginning to climb toward the victim. Then the search and the approach, finding the climber and getting to a position from which they can actually be reached, which on steep ground may mean the long line, a rescuer swinging beneath the aircraft on a rope. Then the transfer, getting the victim secured and loaded, itself difficult and dangerous on a slope or in wind. And only then the flight down. Every one of those stages takes time. Every one of them can be stopped cold by weather. And the weather that caused the emergency is very often the same weather that shuts the whole chain down at stage 1. You can see the entire machine and its hard limit in a single incident from the spring of 2023. A 24-year-old climber at the 14,000-foot camp began to go downhill fast. First groggy, a slight headache, the kind of thing that is easy to dismiss, and then quickly, the full picture of severe altitude illness, the brain and the lungs both failing at once, the swelling and the fluid, the medical emergency that the physiology says must be answered by immediate descent. The recognition happened. The climber was in the best possible place to be sick on Denali at the ranger camp, with trained rescuers and a medical tent and a hyperbaric chamber right there. The call for a helicopter evacuation went out. And the weather said no. On the night of the 30th of May, the conditions would not allow the helicopter to fly. Not because anyone lacked the will or the machine or the training, but because you cannot fly a helicopter into weather that will kill the crew. And the same system that was making the climber sick, or a related one moving through, was keeping the aircraft on the ground. So the rescue could not proceed to its final stage. And what the Rangers did instead is the truest picture of what this mountain actually demands. They did not wait for the sky to clear. They ran 18 hours of advanced life support on that patient by hand, at 14,000 feet, cycling the climber through the hyperbaric chamber to simulate the descent the helicopter could not provide, giving supplemental oxygen, doing the work of a hospital in a tent on the side of a subarctic mountain for 18 hours, until a window finally opened and the flight could go. The climber survived. But look at what it took. Not a swift, clean helicopter rescue, but 18 hours of relentless human effort to hold a person at the edge of death because the technology that was supposed to save them could not launch. The machine was ready. The mountain would not let it fly. That is the modern reality, and it is not a story of failure. It is a story of a superb rescue system running straight into a limit it cannot cross. The helicopter did not fail. The Rangers did not fail. Physics did not fail. Everything worked exactly as designed. And it still came down to 18 hours of people breathing for a stranger by hand because the weather held the door shut. Multiply that by every emergency that happens not at the 14,000-foot camp but higher, on the Autobahn or above, where there is no medical tent and no hyperbaric chamber and no ranger standing by. Where the stricken climber is simply up there in the cold, and the only help is hours away on foot, or grounded by the same storm that caused the crisis. And you understand why the death toll for all the improvements has never gone to zero and never will. And there is the piece of it that the people who do this work carry and rarely say out loud. To run that chain, the rescuers have to enter the same mountain. The ranger climbing toward a sick party above high camp is breathing the same thin air and crossing the same crevassed ground and exposed to the same cold. The volunteer hanging under the helicopter on the long line is in the same wind that is battering the victim. The pilot flying at the edge of the machine's capability in thin, turbulent air over brutal terrain is one gust from becoming a second emergency. Denali has injured and nearly killed the people trying to save others on it, because there is no way to reach a person in that environment without being in that environment. Help does not descend from some safe place outside the danger. There is no outside. The rescuer and the rescued stand on the same ice under the same sky, subject to the same physics, and the only thing separating them is that one of them is, for now, still able to move. To understand why so many people end up on that same ice, you have to go back to the man who drew the map, literally drew it, and turned Denali from a mountaineer's gamble into a route that ordinary strong climbers could follow. His name was Bradford Washburn, and he did more to shape how people climb Denali than anyone before or since. In 1936 and 1937, he flew over the mountain and took the first large-format aerial photographs of it, capturing its architecture in a way no one had ever seen. He studied those photographs the way a general studies terrain, and in them, he saw a line up the mountain that no one had climbed. A route up the west side that others warned him was suicidal. In 1951, with his wife Barbara and a small team, he climbed it and proved the warnings wrong. That line is the West Buttress, and today around 90% of everyone who climbs Denali climbs Washburn's route. In 1960, he produced a detailed topographic map of the mountain, so precise that climbers and scientists still use it. Here is the irony sitting inside that achievement. Washburn's route is the safest, most logical lineup Denali. That is exactly why it became the standard. And precisely because it is the safest and best-known line, it is the line that funnels the largest number of people into the mountain's danger zone. The West Buttress did not make Denali safe. It made Denali attemptable by the many, and the many, on their schedules, with their finite windows, are the raw material the mountain works with. The same route that keeps thousands of climbers off the truly murderous technical faces delivers those same thousands to the high camp, and the Autobahn, and the thin air, and the storms. A good route on a killer mountain does not remove the killing. It organizes the traffic into it. And moving along that route, camp by camp, is not the clean, heroic march people imagine. It is weeks of heavy, repetitive, cold labor. Because a climber cannot carry 3 weeks of food and fuel and gear up the mountain in a single push, the West Buttress is climbed by relaying loads, carrying a portion of the supplies up to the next camp, caching it, descending to sleep low, then moving up again. Climb high, sleep low, over and over, which is also, not coincidentally, exactly the pattern the body needs to acclimatize. The mountain forces a rhythm that happens to be the safe one, and even that rhythm is not enough to protect everyone. Every load is dragged on a sled or hauled on a back across a glacier seamed with hidden crevasses. The team roped together, each person watching the snow ahead for the faint sag or the subtle discoloration that betrays a bridge over a void. Then there is the problem of simply knowing where you are, which on Denali is not a given. When a storm closes in, or even when cloud settles over the upper mountain, the world can turn white. Not foggy, white. A condition where the snow underfoot and the air above it become the same featureless nothing, and the horizon ceases to exist. In a full whiteout, a climber can lose the ability to tell up from down, to see the slope they are standing on, to know whether the next step is onto flat snow or over an edge. People have walked off drop-offs in whiteouts. People have wandered in circles 100 yards from camp and not found it. The defense against this is almost comically low-tech, and it is one of the small, telling human behaviors that reveal what the mountain actually demands: the wand. Climbers mark their route with thin bamboo garden stakes topped with little flags, planting them every so often on the way up, so that on the way down, exhausted, hypoxic, in weather that may have erased everything, they can follow the line of wands home like a trail of breadcrumbs. A person's life on the upper mountain can come down to whether they placed enough bamboo sticks in the snow on the way up, and whether they can still see the next one through the blowing white. Live inside that for a moment, because it is the texture of the real thing. At the 17,000-foot high camp, there is no shelter but the tent you carried, and the walls of snow blocks you cut and stacked around it by hand to break the wind. There is no water but what you make by melting snow over a small stove, a process that at altitude and in cold takes far longer than it should and burns fuel you have to ration, because when the fuel is gone, you cannot make water, and without water you dehydrate. And dehydration at altitude is not discomfort. It is the accelerant that speeds frostbite and altitude illness and the fogging of the mind. Everything is slow. Everything is cold. Putting on boots is a project. A dropped glove is a crisis. The stove is life. The tent is life. The wands are life. And every one of these fragile, mundane things stands between a human body and an environment that, if any of them fails at the wrong moment, will begin killing that body in minutes. This is not adventure as a poster imagines it. It is a long, disciplined, exhausting effort to keep a set of small systems working in a place that is constantly trying to shut them down. And the people who survived Denali are, more than anything, the people who kept the small systems working and knew when to turn around. The dead are the mountain's most visible toll, but they are not its whole toll. Denali also takes pieces of the people who survive it, and the way it does that reveals the cold as a mechanism, rather than just a number on a thermometer. To see it, you have to understand what freezing actually does to a living hand or foot, because it is not simply pain, and it does not stop when the person gets warm. When flesh is exposed to enough cold, the body makes a decision on the climber's behalf, and it is a ruthless one. To protect the core, the heart, the brain, the organs that must stay warm for the person to survive at all, the body clamps down the blood vessels in the hands, the feet, the nose, the ears, and pulls the warm blood inward. The extremities are sacrificed to save the center. That is why frostbite takes the fingertips and the toes and the tip of the nose first. They are the parts the body is most willing to abandon. And once the blood retreats and the tissue itself begins to freeze, ice crystals form inside the cells and destroy them. The damage is often done before the climber fully registers it, because deeply frozen tissue goes numb. The screaming pain of early frostbite gives way to a deceptive nothingness, and a person can keep climbing on feet that are quietly dying inside their boots, feeling almost nothing, until they take the boots off, far too late. This is why the small behaviors matter so much, and why experienced Denali climbers are almost fussy about their hands and feet, in a way that looks like paranoia until you understand the stakes. They wiggle their toes constantly to keep the blood moving. They swing their arms hard to force warm blood back into their fingers. They guard their mittens as if their lives depended on them, because a hand exposed at that wind chill has, as the weather station proved, well under a minute before the damage begins. They will stop a summit push to deal with a foot that has gone numb, because they know that pushing on means losing it. The discipline is not cowardice. It is arithmetic. A summit is not worth a foot, and the climbers who forget that arithmetic in the grip of summit fever are the ones who come home to the surgeon. And they do come home to the surgeon, in numbers. For every climber Denali kills, there are others who survive with frostbite severe enough to cost them fingers, toes, and sometimes more. The damaged tissue, once it is thawed, and the extent of the death becomes clear over the following days and weeks, frequently cannot be saved. And the surgeons take what the mountain has already killed. People have summited Denali and paid for it with their toes. Some have paid with their fingers. These are not freak outcomes. They are a routine category of injury on the mountain, common enough that the medical literature on Denali treats cold injury as one of its signature harms alongside the falls and the altitude illness. The mountain does not have to kill you to permanently change your body. It can simply take the parts that stray too far from your core for too long and hand the rest of you back diminished. Hypothermia is the same logic aimed at the whole person instead of the extremities. As the core temperature falls, the body first shivers violently, throwing everything it has at generating heat. Then, as it keeps falling, the machinery starts to fail. The shivering stops, which feels like relief, but is actually a catastrophe, the body giving up its last defense. Coordination collapses. Thinking slows and then distorts. In the strange, well-documented final stages, some hypothermia victims feel a paradoxical rush of warmth and begin removing their clothing, and some crawl into small spaces, behaviors that have been recorded again and again and that make the discovery of the bodies all the more haunting. Long before that endpoint, though, hypothermia has already done the thing that makes it so dangerous in a place like this. It has degraded the victim's judgment and coordination at the exact moment those are the only things that could save them. It is the same trap as the cerebral edema, the same trap as the exhaustion on the Autobahn. The mountain attacks, first and hardest, the very faculties a person would need to escape it. Cold, altitude, and fatigue all converge on the same target, which is the climber's ability to make good decisions, and they take it away right when everything depends on it. So when you read that someone died of exposure on Denali, understand that exposure is not a vague or gentle word. It is a precise physiological process with stages, and every stage is a further narrowing of the victim's options, engineered by the environment. And understand, too, that the survivors carry the mountain with them, in the missing joints, the numb patches that never fully recover feeling, the toes that had to go. The line between the people Denali kills and the people it merely marks is thinner than the summit photographs ever show, and it is drawn, more often than not, by a matter of minutes and a few degrees, and whether someone had the discipline to turn around while they still could. Knowing all of this, the storms that sit for days, the air that drowns the lungs and swells the brain, the slope that funnels a slip into a fatal slide, the cold that takes fingers in under a minute, the rescue that the weather can veto. You would think the sensible thing would be for people to stay away. They do not stay away. More than 1,200 climbers attempt Denali every single season, and the number has held or grown for decades. The question the Koyukon answered by staying home is a question the modern world keeps answering the opposite way, and it is worth understanding why, because the why is the human engine that keeps feeding the machine. It starts in a small town called Talkeetna, at the end of a spur road off the highway between Anchorage and Fairbanks. Talkeetna is the gateway to Denali, and it exists in its climbing season as a staging ground, a place of gear shops and ranger stations, and above all, air taxis. The bush pilots of Talkeetna are the true enablers of the modern mountain. Flying ski-equipped aircraft, some of them twin otters. They carry climbers from the town to the Kahiltna Glacier at around 7,200 feet, landing on a groomed strip of snow that in the busy season becomes a small, temporary city of tents known as base camp, complete with a camp manager who coordinates the flights in and out. That flight, 30 or 40 minutes of stunning, terrifying air over the Alaska Range, is what collapses the mountain from a months-long wilderness expedition into something a person with a job and a few weeks of vacation can realistically attempt. The bush pilots did for Denali what the airplane did for every remote place. They annihilated the distance that used to protect it. And once the distance is gone, the pull takes over. And the pull on Denali is unusually strong because of what the mountain is. It is the highest point in North America, and that single fact places it on one of the most powerful lists in modern adventure, the 7 summits, the highest peak on each of the 7 continents. Climbing all 7 has become a defining goal for a certain kind of ambitious mountaineer, and Denali is one of them, often described as the hardest of the 7, the one that humbles people who have already stood on top of Kilimanjaro and Aconcagua, and even Everest. That reputation is a magnet. It draws climbers who are chasing the list, some of whom have real high-altitude experience, and some of whom have far less than the mountain demands, all of them pulled by the same idea, that Denali is a box to be checked on the way to something larger. The mountain does not care about the list. It applies the same physics to the 7 summits collector as to everyone else, and the list has delivered to its slopes plenty of people whose ambition outran their preparation. Then there is the guiding industry, which sits on top of all of this and shapes it. Roughly half of everyone who attempts Denali goes with a professional guide service, and the guides genuinely improve the odds. Guided parties summit at meaningfully higher rates than independent climbers, something like 55 to 70% against 35 to 45, because the guides bring experience, establish camps, and, most importantly, the judgment to turn a client around. But the guiding industry also embodies the central tension of the whole mountain. It is a business. It sells summits, or the serious chance of one, and its clients arrive having paid a great deal of money for that chance, on a fixed itinerary, with the summit as the thing they came for. A guide who turns clients around in marginal weather is doing exactly the right thing, and is also, in that moment, disappointing paying customers and testing the reputation the business runs on. Good guides carry that tension well and turn people around anyway, and it saves lives. But the pressure is always there, on both sides of the rope, pushing toward the summit and away from the patient. Boring, life-preserving decision to wait or to quit. Look at the overall success rate, and you can read the mountain's answer to all this ambition written in a single number. Across all the climbers who attempt Denali, only about half reach the summit. Half. In a good weather year, it climbs above 60%. In a bad one, it can fall toward a quarter. That is not a number produced by a mountain that lets prepared people through as a matter of course. It is the number of a mountain that turns half of everyone back, most of them not by killing them, but by simply refusing to grant the weather window, the acclimatization, the day of calm on the summit that a successful climb requires. The 1,200 who come each year are, collectively, rolling dice against the weather, and the mountain keeps roughly half the stakes. The ones who go home without the summit are the lucky majority who read the dice correctly or who had a guide who did. The ones who die are the small fraction for whom the timing went wrong at the worst possible moment, high on the mountain, with an option disappearing. That is the exposure the modern era has built, not a handful of elite expeditions accepting a known risk, but a steady stream of over 1,000 people a year, of wildly varying experience, flown past the old protective distance and delivered to the base of a mountain whose fundamental dangers, no flight, no guide, no forecast, and no rescue helicopter has been able to reduce. The demand keeps rising because the reasons for it, the highest point on the continent, the 7 summits, the accessibility, the achievement, are all still there, and they are the same reasons that make the mountain worth the risk to the people who take it. Denali is valuable for exactly the thing that makes it deadly. It is the biggest, the highest, the hardest of its kind on the continent. You cannot separate the draw from the danger. They are the same fact, seen from 2 sides. There is one more force acting on this mountain, and it is the newest, and it is changing the terms of the whole problem in a way that is easy to misread. The Alaska Range is warming, and it is warming faster than most of the planet. Alaska's average annual temperature has been rising by roughly 0.6 of a degree Fahrenheit every decade since 1950, a rate far above the global average, because the high latitudes are heating fastest of all. The very latitude that makes Denali's air so thin also puts it in the part of the world where the climate is shifting most quickly, and the mountain is registering that shift in its ice. The Kahiltna Glacier, the highway of the West Buttress, the surface every climber walks up, the strip where the bush plains land, is losing mass and growing thinner. Across the whole park, the glaciers that covered 1,339 square miles in 2020 had shrunk by 14% from what they were in 1985, and the rate of loss is accelerating, faster now than it was in the second half of the 20th century. This is not a distant, abstract statistic. It is remaking the ground under the climber's feet, and here is the trap inside it. The reversal that catches the intuition off guard. A warming mountain is not a safer mountain. You would think that less cold would mean fewer of the cold's victims, and perhaps at the margins it does. But warmth on a glaciated peak strengthens a different set of hazards even as it weakens the cold, and the ones it strengthens may be worse. Follow the mechanism. Warmer temperatures mean the snowpack softens earlier in the season, and the deep, cold snow that bridges the crevasses turns weak sooner. Those snow bridges are the only thing letting climbers walk across a glacier. That is, underneath, a maze of 100-foot voids. As they rot out earlier each year, the window of relatively safe glacier travel narrows, and the odds of a bridge collapsing under a climber, the exact way Mug's stump died, rise. Late-season climbers now find the Kahiltna more broken, more open, more seamed with gaping crevasses than climbers of a generation ago did at the same date. The base camp runway itself is affected. The strip the ski planes rely on becomes unusable earlier as the melt progresses and exposes the crevasses beneath it, shortening the window in which climbers can even be flown in and out. Rock faces that were once locked together by permanent ice are losing that ice and shedding rockfall onto roots that used to be frozen solid, and the storms, by the observations of the people who work the mountain, are running greater and more prolonged than before. So the warming does not lift the siege. It reshuffles it. It trades a little of the extreme cold for more crevasse exposure, more rockfall, more unstable snow, a shorter and more crowded safe window, and storms that may sit even longer than the one that killed the Wilcox Party. This is the same pattern that has run through the entire history of the mountain, now written by the climate itself. Change one variable, and the danger does not disappear. It migrates. The forecast solved surprise and left distance untouched. The airplane solved access and enlarged exposure. The guides raised the floor and could not lower the ceiling. And now the warming climate softens the cold and hardens the ice hazards. And the net for a climber standing on the Kahiltna is not obviously better. It is different. The system that makes Denali lethal is not a fixed list of dangers you can check off and defeat one by one. It is a set of forces that redistribute themselves every time one of them is pushed. And it has been doing that for over a century. That is the honest shape of it. And it is worth resisting the easy version in both directions. The mountain is not getting safer, because it is getting warmer, and it is not necessarily getting deadlier in some simple, linear way either. What is happening is that the specific mix of ways it can kill is shifting under the climber's feet, faster now than at any time in the recorded history of climbing there. While the number of people exposed to that shifting mix stays high, and the fundamental engine, thin far north air, storms off the sea, a funnel of terrain, and a rescue that the weather can always ground, runs exactly as it always has. The reforms of the 1990s worked on the people. The technology worked on the information and the access. Nothing has worked, or can work, on the mountain itself because the mountain is not a problem to be solved. It is a place with a fixed position on the globe and a fixed relationship to the atmosphere. And the only variable anyone has ever really controlled is whether or not to go. So return, finally, to the question that has been running under all of this since the first 100 words. Why does a mountain thousands of feet shorter than the Himalayan giants kill experienced, well-equipped people who did almost everything right? You now have the whole answer, and it is not a single thing. It is a chain. And the chain is what makes Denali what it is. It begins with geography, and specifically with an accident of position. Denali stands at 63 degrees north near the top of the world, and that latitude does two things at once. It thins the air so that the summit's 20,300 feet punish the body like 23,000, pushing climbers into the zone where the lungs fill and the brain swells. And it places the mountain directly in the path of the storm systems that spin off the Gulf of Alaska and the Bering Sea, an endless supply of violent weather with nothing between the ocean and the peak to slow it down. Geography sets the trap. A mountain that is physiologically higher than its height and meteorologically exposed to some of the worst weather on the continent, standing alone with 18,000 feet of naked vertical relief for the wind to accelerate against. Then weather activates the trap. Most days, most of the season, the mountain merely tests people. But when one of those ocean-borne systems slams into the range and rides up over Denali, the wind reaches hurricane force and the cold combines with it to produce wind chills that can kill exposed skin in under a minute. And this is the part that separates Denali from mountains that are merely stormy. The weather does not pass in an afternoon. It can sit on the summit for days. That duration is the weapon. It does not need to strike a single killing blow. It only needs to outlast the food, the fuel, the water, and the body heat of whoever is caught above it. And it has the patience to do exactly that. The force those first two produce, the wind, the cold, the thin air, the moving ice, then goes to work on human bodies and human equipment, and it finds them because human motive keeps putting them there. This is the piece no amount of physics explains on its own. People go up because the mountain is the highest on the continent, because it is on the list they are chasing, because they have flown thousands of miles and paid thousands of dollars and taken the time off and cannot bear to waste the window, because a guide's season depends on summits and a climber's pride depends on the top. The Koyukon, who had no schedule and no summit to prove, simply did not go, and that restraint was the single most effective safety measure in the entire history of the mountain. Everyone since has arrived carrying the one thing the Koyukon left at home: a reason to override the mountain's terms. The exposure is not an accident. It is manufactured every season by more than 1,000 people choosing to enter. Technology then changes what those people can attempt, and every tool has followed the same double-edged logic. The airplane erased the distance and delivered the crowds. The radio and the satellite phone let a climber report their own emergency without being able to escape it, as Uemura proved by summiting, calling it in, and vanishing on the same descent. The forecast warned of the storm but could not move a tired body down the mountain in time. The guide raised the odds but could not repeal the weather. Each advance solved a real problem and, in solving it, opened a new exposure or ran headlong into a limit it could not cross. Technology on Denali has never been useless and has never been enough. It has consistently moved the danger rather than removing it. And underneath all of it sits distance, the plain, unglamorous fact that help is far away and can be kept far away by the very conditions that make it necessary. This is the wall every era hits. In 1967, it grounded every possible rescue while 7 men died within radio range of teammates who could do nothing. In 1984, it swallowed the most capable adventurer alive, despite a working radio. In 2023, it held a superb rescue helicopter on the ground for the 18 hours that rangers spent breathing for a dying climber by hand. In 2026, it forced a long-line extraction on the Autobahn that saved one of 4 and could not reach the rest in time. The same conditions that create the emergency prevent the rescue. Not sometimes. As a rule. It is the most consistent fact in the mountain's entire record, and it has survived every improvement in aircraft, communication, and medicine that the last 60 years produced. Then history closes the loop, because the most damning evidence that this is a system and not a run of bad luck is that the same trap keeps catching different people across completely different eras. The wool and hemp expedition of 1913 and the satellite phone expeditions of today climbed the same funnel of terrain into the same thin air under the same storms. 7 died in 1967 and 3 died in 2026 in strikingly similar ways. Caught high on the descent by conditions that turned a reasonable decision into a fatal one while help was blocked by weather. The names change, the gear changes. The mechanism does not. When the same accident recurs across a century through every level of technology and skill, you are no longer looking at individual mistakes. You are looking at the fixed properties of a place, expressing themselves through whoever happens to be standing there when the variables line up wrong. That is the whole answer. Denali kills the experienced and the well-equipped, not despite their competence, but because competence was never the deciding variable. The deciding variables were the latitude, the weather, the duration, the terrain, the distance, and the schedule the climber carried up with them, and of all of those, the only one any human being has ever controlled is the last. Everything the modern world has thrown at this mountain has been an attempt to control the others, and none of it has worked, because none of it can. The mountain is not a puzzle with a solution. It is a set of conditions, and it has never changed its terms. It is worth being precise about that word, lethal, because the honest version is more interesting than the marketing version. If you rank North American mountains by the sheer number of people who have died on them, Denali is not actually at the top. Mount Rainier in Washington state has killed far more, well over 400 people since the late 1800s, the highest recorded climbing death toll in the United States. Denali's confirmed toll since 1932 sits closer to 130. By raw count, Rainier wins the grim contest, and any honest telling has to say so. But raw count is a crude measure because it does not account for how many people are exposed or who they are. Rainier sits a short drive from a major city, and enormous numbers of people set foot on it, from day hikers to elite climbers, which inflates the total. Denali is at the end of a bush flight into the subarctic, attempted by only around 1,200 people a year, nearly all of them serious, prepared mountaineers who chose one of the hardest climbs on the planet. And it still kills them at a rate of roughly 3 deaths per 1,000 summit attempts, and it produced the single deadliest mountaineering disaster in North American history in 1967, and its worst season killed 11. And among its dead are some of the most accomplished climbers who ever lived. Denali is not the mountain that kills the most people. It is the mountain that kills the most capable people, the ones who should by every measure survive it, and it does so with a completeness that the more crowded, more accessible peaks cannot match. That is a defensible meaning of lethal, and it is the one this mountain has earned. Part of what earns it is what the mountain does with the people it takes, which is often to keep them. This is one of the quiet, hard truths of Denali that separates it from a peak you can walk off of. When someone dies high on this mountain, in many cases their body is never recovered, because recovering it would mean sending living rescuers into the same lethal terrain and weather that did the killing, for no possible benefit to the person already gone. So the mountain keeps them. 4 of the 7 from the Wilcox expedition were never found. They have been somewhere on the upper mountain, moving slowly downward inside the glacier for approaching 60 years. Naomi Uemura, the greatest solo adventurer of his age, was never found. The winter took him and did not give him back. Mug Stump, one of the finest alpinists America produced, is still inside the crevasse that collapsed under him on the South Buttress, where he has been since 1992. The mountain is, in a real and literal sense, a graveyard that never yielded its bodies, and every climber who walks up the Kahiltna is walking over people, some of them famous, all of them once as alive and capable and ambitious as the climbers stepping over them now. That fact changes the character of a recovery operation on Denali, and it is worth understanding what one actually involves, because it is the rescue problem turned inside out. When a body can be recovered, the operation runs through the same brutal chain as a rescue: recognition, authorization, a team assembled, a flight or a climb up into the terrain, the approach, the extraction. with one crucial difference. There is no longer any reason to accept the same level of risk because there is no life left to save. So the recovery waits. It waits for weather, sometimes for weeks, sometimes across seasons, sometimes forever. Rangers and volunteers will not die to bring down someone who is already dead. And they should not. And so the decision of whether a family gets a body back is made not by grief or by will, but by the same indifferent variables that govern everything else on the mountain: the weather, the terrain, the distance, the cold. The mountain that decides who lives also decides who comes home, and it decides both by the same logic, which is no logic at all, only physics. And still they come. That is the fact that outlasts every disaster, every reform, every improvement in gear and forecasting and rescue. The Wilcox disaster did not empty the mountain. Uemura's disappearance did not empty it. The deadliest season in the range's history did not empty it. Every spring, as the light returns to the Alaska range and the worst of the winter cold begins to ease, the bush plains fire up in Talkeetna, and the tents reappear on the Kahiltna, and another 1,200 people begin the slow relay up Washburn's route toward the thin air and the storms and the Autobahn, knowing all of it, having read the accounts, having seen the numbers. They come because the reasons to come have never gone away. It is still the highest point on the continent. It is still one of the 7 summits. It is still there, standing alone out of the lowlands, the largest thing for 1,000 miles, exactly as visible and exactly as tempting as it was to the prospectors and the missionaries and the first men who dragged themselves up it in wool coats. The draw is permanent, and so therefore is the danger, because they are the same thing. If you want to feel how all of these forces converge into a single afternoon, follow an ordinary, well-run summit day up the West Buttress, the kind that happens dozens of times in a good season and ends, most of the time, with everyone back in their tents. It starts in the dark and the cold at the 17,000-foot camp, a party pulling on frozen boots and choking down what food they can, because the plan on Denali is almost always to start early and give the long day the widest possible margin of daylight. They rope up and step out into air that at that hour, even in the climbing season, can sit far below zero. And the first thing in front of them is the Autobahn, the tilted traverse of hard snow and ice they must cross to reach Denali Pass. In the morning, fresh, this is manageable. They front point across it, crampons biting, and clip into the fixed protection where it exists. And they reach the pass and turn upward. From Denali Pass, at 18,200 feet, the route grinds up through a series of features with the plain, functional names climbers give to suffering. The long slog to the football field, a flat expanse near 19,500 feet that offers a cruel psychological trap, because it looks like the top and is not. And above it rises Pig Hill, a final steep pitch that at that altitude, on legs that have been climbing for hours, in a third less oxygen than the body wants, feels like the hardest thing a person has ever done. Every step up there is a deliberate act. The pressure breathing, the forced hard exhale to drive a little more oxygen exchange becomes automatic and necessary. The pace slows to something that from below would look absurd, a step and a rest, a step and a rest, because the body simply cannot be hurried in that air. And the whole time, the clock is running. And the weather that was clear at dawn is a thing that must be watched, because a clear morning on Denali is a promise the mountain does not always keep. Then the summit ridge, narrow and corniced and exposed on both sides, and then the top, 20,310 feet, the highest point on the continent, a small crowded spot in the sky where the successful stand for a few minutes and take the photographs that will hang on their walls for the rest of their lives. And this is the moment the whole story has been pointing at, the moment that is not a triumph, but a hinge. Because the summit is not the end of the day. It is the midpoint of the most dangerous day, reached by people who have just spent everything they had to reach it. And now every single thing they did to get up there has to be undone, in reverse, on the same terrain, with less light and less strength, and a body that has been at extreme altitude for hours and is deteriorating with every one of them. The descent is where the numbers become people. Far more of Denali's dead were lost coming down than going up. Down the summit ridge, down Pig Hill, back across the endless false summit flat, back to Denali Pass. And there, at the top of the Autobahn, is the exact spot where more people have died than anywhere else on the route. Waiting for them at the worst possible moment. Now they are exhausted. Now the fine control in their legs is going. The crampon placement that was precise in the morning, getting sloppy as the muscles fail. Now if the weather has turned while they were high, the traverse they crossed in calm morning light may be swept by wind and blowing snow. The fixed protection hard to find. The run out below them, disappearing into white. A slip here does not forgive. On hard ice, an exhausted climber who loses their feet has perhaps a second to arrest the fall with their axe before they are moving too fast to stop, and an exhausted, hypoxic climber very often does not make that arrest in time. If they are roped to teammates who are equally spent, the falling body can pull the whole team off the slope. This is the mechanism behind so many of the mountain's worst descent accidents, and it is why that ordinary-looking traverse is the deadliest ground on Denali. Most days, none of this happens. Most days, the party crosses the Autobahn one more time in the fading light, drops back down to the tents at 17,000 feet, and collapses, safe, into their sleeping bags. And in the morning, they start down the mountain toward the glacier, and the airstrip, and home, and they become one of the roughly half of all attempts that succeed. That is the crucial thing to hold on to, the thing that keeps this from being a simple horror story. Denali is not constantly killing people. It is mostly letting them pass. The disasters are the exceptions, the days when a variable that is usually benign, the weather, the timing, a snow bridge, a slip, a headache that turns out to be the brain swelling, lines up wrong at the one altitude and the 1 hour where there is no margin left to absorb it. The mountain is not a monster that devours everyone. It is a place with almost no room for error, that most of the time you get across without needing any, and that on the rare day you do need it, does not have any to give. That is the whole terrible economy of the place, and it is why competence is not the protection people assume. Competence buys margin, and on Denali the margin is so thin to begin with that even a large amount of competence can be eaten through in a single bad afternoon by forces that do not care how skilled you are. The best climbers on the mountain know this. It is why the good ones are, by the standards of ordinary life, almost cowardly about turning around. Why they will abandon a summit a few hundred feet from the top on a day that looks fine, because something about the light or the wind or the hour told them the margin was gone. They have understood the thing the mountain has been teaching since 1913. The thing that the Koyukon knew without ever climbing it, that on Denali, survival is not mostly about how well you climb. It is about how honestly you judge when not to. The season on Denali is short, and it ends the way it begins, on the glacier with an airplane. By late July, the warming that is remaking the mountain has softened the Kahiltna, opened the crevasses, and begun to eat the snow runway that the whole operation depends on. The bush pilots watch it close. The climbers who are coming down off the mountain in those last weeks are racing a deadline that has nothing to do with the summit and everything to do with whether the strip will still hold a ski plane when they get there. And then, one clear morning in a break, between the systems moving off the Bering Sea, A small fixed-wing aircraft drops out of the sky onto the glacier at 7,200 feet, taxis up to the cluster of tents, and takes on a load of climbers who 3 weeks ago walked off this same ice going the other way. Watch it lift off. The plane accelerates down the snow, skis hissing, and rises into the thin, bright air, and it banks away from the mountain and drops toward Talkeetna and the green lowlands and the road and the world. And the sound of its engine fades until the glacier is silent again. The climbers in it are going home. Some of them summited. About half of them did not. All of them are, for now, among the ones the mountain let pass. And above them, as the engine noise dies, the upper mountain is already doing what it always does. Look up from the airstrip, and the summit is trailing a long white plume of blown snow off its ridges. The unmistakable sign that the wind up high is rising again, that another system is stacking up over the Alaska range, that the window that let this one plane out is already beginning to close. Somewhere on that peak, above the reach of the aircraft that just left, the temperature is falling, and the barometric pressure is doing the quiet, lethal arithmetic it has done for as long as the mountain has stood at 63 degrees north. The snow bridges over the crevasses are weakening in the day's warmth. The Autobahn is holding its hard tilt of ice. The four from 1967 and the man from 1984 and the climber from 1992 are still up there under the moving glacier, and they are not going anywhere, and neither is the mountain. Next spring, the light will come back, and the cold will ease just enough, and the planes will fire up in Talkeetna, and 1,200 more people will step out onto the Kahiltna and start up Washburn's route into the thin air, because it is still the highest point on the continent, and that has never stopped being reason enough. Most of them will come home. A few will not. The mountain will decide which, the way it always has, by the weather and the timing and the distance and the terrain, and not by how much any of them wanted it or how well any of them climbed. The plume of snow will keep streaming off the summit into the wind. The window will keep opening and closing, and Denali will keep doing the only thing it has ever done, which is to stand exactly where it is and wait.